Hello everybody, welcome to the Soil Physics Lab of Lal Carbon Center at the Ohio State University. Today, I'll demonstrate how we measure soil porosity using a digital picnometer. This method allows us to determine particle density, which is a key parameter for calculating total soil porosity. Why porosity matter? Let's talk about it. Soil porosity represents the fraction of soil volume occupied by pores. These pores control water retention, aeration, root growth, and microbial activity. In soil physics, porosity is not measured directly, it is calculated using bulk density and particle density. You can see here is the equation to calculate the porosity. Let's talk about the role of picnometer. This digital picnometer measures particle density by determining the true volume of soil solids using gas displacement, usually helium or nitrogen. We are using nitrogen gas cylinder here to supply nitrogen gas to this picnometer chamber. Because this kind of molecules like nitrogen or helium are extremely small, they penetrate even fine pores between soil particles, giving a very accurate solid volume. Let's talk about the sample preparation. You can see in my hand, those are the soil samples I'm using for measuring the picnometer measurement. Before using the picnometer, soil samples must be air dried and sieved to less than 2 millimeters to remove gravel and plant residue. We then weigh a known mass of soil, typically between 5 to 10 grams. Moisture or organic debris can introduce error, so proper sample preparation is critical here. And then loading the samples. We will load the samples here, and it should be carefully done after taking the weight of that sample. The chamber must be cleaned and dry before loading. And then close the lid firmly. We have to close this lid very tightly, and then running the measurement. You can see here is a button for 0, and here is another one for vent, here is another one for fill. So we will remove all the gas in the chamber by using this open or close. So we will do this to open, and all existing air would remove from here. And when it would be near 0, we will use this to make it exactly 0, and then we will close it, and then we will use the fill part and we'll open it. Thus the nitrogen gas from this cylinder would pass through this to this, and then the air is entering into this chamber. When it would be around 19.5, we will close this to stop the air to enter into the chamber, and then we will wait to be stabilized this, as we are expecting around 19.5. So we are getting that value, and then we will use this from preparation to test. So now it's in preparation, and we will take it to the test section, and then we will take another measurement. So we will note it down here. Using this value, we will calculate the particle density. Let's talk about the particle density. It's calculated as the mass of soil divided by volume of soil solids. You can see here is the equation to calculate the particle density. Once you know particle density from the picnometer and bulk density from core samples, we can calculate total porosity. You can see here is the equation to calculate the total porosity using the particle density and bulk density data we have. This gives us the fraction of soil volume that can store air and water. Why this digital picnometer is reliable? Digital picnometer is highly accurate because gas penetrates micropores that liquid methods can't access. This makes it essentially suitable for soil with fine texture or high aggregation. So this is how we use our digital pictometer to determine particle density and ultimately calculate soil porosity in a soil physics laboratory. This parameter is fundamental for understanding soil hydraulic behavior, plant available water, and overall soil quality. Thank you so much for watching this video. If you found this helpful, please like, share, and subscribe for more soil physics lab demonstrations.